start. Today, we're going to go ahead and apply system of or matrices to solve a system of equations. Okay? Before we go into that, let's go ahead and learn first how do I set up a system of equations or matrices for system of equations. Given any system of equations, say for instance, if I have x plus 2y equal 11, and then we have 2x plus y equals 10. So this is a system of equation. Yeah. We can rewrite this in matrix form. First matrix we're going to introduce is the augmented matrix. And that matrix consists of the coefficient of the variables and the constant. So that would be on the first column, we will write all the coefficients of x. So we have 1 and 2. So 1, 2. The second column would be the coefficient of y. So we have, say, 2, 1. And then if we have more letters or more variables, we keep writing their coefficient one by one. So maybe x, y, z, w, what have you, in any form. Yes? And then we have, after we're done with that, so we can write the constant or your 11 and then 10. Okay? 11 and 10. So this augmented matrix represents this system of equations. So if I'm looking at the matrix itself, without looking at the equations, can say, well, x plus 2y equal 11, then 2x plus y equal 10. If for any reason you want to change the order of the letter, that's up to you, as long as you specify what they are. Normally, they go x, y, and z, and so on. But if you choose, you want to say, I want to write y over here, make sure you put a y on top so people can know that this is your y value. Okay? But in general, common standard is x, y, z, and so on. Okay? Now, the first part of it, if I write that in a matrix by itself, so 1, 2, 2, 1, that would be a 2 by 2. This is called the coefficient matrix. And that would represent the coefficient of those variables you have. If I were to write the last one by itself, 11 and 10, this would be the constant matrix. This would be the constant matrix. Okay? Now, so let's go ahead and deal with the augmented matrix. Augmented matrix represents all the equations, right? So whatever you can do, whatever you do on the equation, you are allowed to do on the matrix itself. Okay? So we have some row operations because each row represents an equation, so we have certain row operation we can do. For instance, we can multiply a row by a number. Okay? As long as I multiply all the row, so that means the new matrix that I'm going to get is going to be equivalent to that one. Yes, because they're still going to give me the same answers for those equations. Okay? So let's go ahead and multiply a row by a number. Say, for instance, I want to multiply row 1 times 2. Okay? So I just say row 1, or let me put it 2, row 1. So that means my next step or my next matrix is going to be the same as this one, except the row 1, because I put my note over here on top next to row 1. That means I'm going to replace this matrix or this row by multiplying it by 2. For whatever reason I have to multiply it by 2, that would be a scenario. Yes? So let's multiply row 1 by 2 and see what we end up with. So when I do multiply it, I multiply the whole row. So 2 times 1 is 2. 2 times 2 is 4. And then 2 times 11 is 22. And then the second one, I really didn't do nothing to it. So I'm just going to leave it alone. Yes? So now this matrix and this matrix are equivalent. Yeah. Same thing we said, we can, when we were doing solve an equation by elimination, at one time we were adding those equations or subtracting. Yes? Same thing. We can add 2 rows together or subtract 2 rows from each other. Say for instance, I want to replace row 2 by simply adding row 1 and row 2 or subtracting row 2 from row 1. Yes? So I can say, for instance, row 1 minus row 2. So that means my next matrix is going to be row 1, which I didn't do anything to, right? And then row 2, what I'm going to do is I'm going to replace it by the difference between these two. Yeah? So let's see what we end up with. Then we have a 2, 4, 22. And then if I were to go ahead and subtract, I end up with a 0. 4 minus 1 is a 3. And then 22 take away 10 is 12. Again, this matrix is equivalent to the original matrix we have. Every time I'm doing something, the equations are changed. Yes? For instance, here we have 2x plus 4y equal 22. Here I have 3y equal 12. Say, for instance, I want to divide a row by a number. I can. Let's divide this, say, row 2 by 3. So if I were to divide over here row 2 by 3, what do I get? In row 1, we get 2, 4, 22. Yeah? Then if I divide this by 3, I end up with 0, 1, and then 4. Yeah. Now, again, these are the same, correct? What's so nice about the last one is we already know the value of y. If I were to write this equation, what do I get? Y equals 4. So now we know y equals 4. If I want to see what x is, I can go original, or I can go up one more. What does this equation say? 2x plus 4y equal 22. I already know what y is, then I can solve for x. Yes? Or I can continue. Let's see how do I continue. Let's say, for instance, I want to say row 1 minus 4 row 2. So in this case, what I'm doing is I'm taking row 1, I'm making an operation between row 1 and row 2, right? And I'm replacing row 1 by that operation. So what do I get? 2 minus 0 is 2. Yeah? Now, 4 minus 4 times 1 is 4. 4 minus 4 is 0. And then 22 minus 16 is 6, 0, 1, 4. So now I can say, for instance, I want to divide row 1 by 2. Now what do I get? 1, 0, 3, 0, 1, 4. And this is equivalent to the original, yeah? But the difference between the two, here we have x equals 3, y equals 4. So if I were to substitute over here, what do I get? 3 plus 8 equals 11. And then 6 plus 4 equals 10. And that's the solution to the system of equation. Of course, I did a whole lot of things that maybe I could have combined all of them together, right? Like for instance, over here I combined several together. You can do the same thing with those. We normally use system of equation, matrices to solve system of equation when we have more than than 2 equations. Let's say 3 equation or 4 equation or 5 equation. It becomes a little bit easier to solve using matrices. Okay? But whatever operation you can do with the equation themselves, you can also do with the row itself. Okay? Let's take an example solving a system of equation with, say, 3 variables. Okay? And we'll explain what we need to do and how to solve it every time. Let's take, for instance, a system 2x plus y minus z equal 2. And then we have x plus 3y plus 2z equal 1. And then we have x plus y plus z equal 2. So now I want to go ahead and write the system of equation. Now, which equation I put first, it really doesn't matter. There are 3 separate equations, yes? For instance, this equation could have been on top, and then these 2 underneath it. This equation could have been on top, and the other 2 underneath it. The best way to write your system of equation, yes? Make sure, try to have the very first number, if possible, 1. Okay? So I want to choose an equation to write on top such that it has a coefficient of 1 for the x. If not, well, then I'll just go ahead and write whatever they have. Yes? So now we have, this is a 2, so definitely I don't want to write it first. Maybe I'll write this one first or this one first, whichever you want. Okay? So let's write this one first. So we have 1, 3, 2, 1. Okay? I'm just going to put that separation over here. That's between the coefficient and the constant. And now I can write either one underneath. It really doesn't matter anymore. So we have a 2, 1, negative 1, and a 2. Then we have 1, 1, 1, and a 2. And this is my system of equation written in matrix form. How do I solve this system? Step number 1 is, I want to look at this column. This is column number 1, right? I want the column 1, row 1 to be whatever it is. but everything underneath it in that column has to become zeros. Yeah? So I want to use this equation or this number such that everything underneath it will be zero. So how do I do that? Well, if I want to make this 2 0, using that means I can multiply this by 2 and subtract. Does that make sense? And the result, I'll put it in row 2. So let's do exactly what we said. This is where the result is, so this is where I'm going to write the operation. I said I'm going to multiply the top row by 2, so 2 times row 1. And then I'm going to subtract row 2. Yeah? So minus row 2. Okay? So now, if I do that operation, this becomes 0. Now I need to make this a 0 again using the first one on top. Maybe subtract it? Yeah? So if this is 1, this is 1, I can just simply subtract. So that's going to be row 1 minus row 3. So now, this operation is going to be here. This operation is going to be here. Number 1 is going to stay the same. So let's go ahead and do that. So 1, 3, 2, 1. Let's do this. So 2 times 1 is 2. 2 minus 2 is 0. 2 times 3 is 6. 6 minus 1 is 5. Remember, you want to be careful. Maybe repeat your calculation a little bit because it's very easy to make a mistake. 2 times 2 is 4. 4 minus 1, that will make it, again, 5. Okay? And then 2 times 1 is 2. 2 minus 2 is 0. So now this is the new operation, the new system. Now let's go to that one. In this one, it's simply subtract. So this minus that. So 1 minus 1 is 0. 3 minus 1 is 2. 2 minus 1 is 1. And then 1 minus 2 is negative 1. Okay? I finish with row 1, column 1. Yeah? Now I want to go to row 2, column 2. Row 2, column 2, which is that one. If possible, before I do anything, I want to make that is 1. Why? Because it's easy to deal with it when it's 1. Okay? How do I make it 1? I just simply divide it by itself. So I'm going to divide row 2 by 5. So let's say row 2 divided by 5. So now we have the new system. We have 1, 3, 2, 1, 0, 1, 1, 0, 0, 2, 1, negative 1. Yes? Now, after I get this to be 1, after I get this to be 1, I want to try to make everything else 0 in that column. Everything else. But I'm not going to do it all at once. I'm just going to do it one by one. Yes? If I make this 1, then I want to make underneath it, everything underneath it to be 0. Using this one. Okay? So how do I make this 0? Well, I can say this minus 2 times that, right? So let's write it down. Row 3 minus 2 row 2. Okay? And you can also do, if you want, row 1 as well. But I said I don't want to do all of them. But if you want to, you can make this 0 by saying row 1 minus 3, row 2. Yeah, and do both operations at the same time. But I want to do one thing at a time because I want to go ahead and explain something when I get to the bottom of it. Okay. So this is 1, 3, 2, 1, 0, 1, 1, 0. Nothing changed, right? So now let's do this. So we have 2 minus 2 is, well, 0 minus 0 first is 0. If this number change, that means you messed up. Okay. 2 minus 1 is, minus 2 is 0. So we have 1 minus 2 is a negative 1. All right? And then we have negative 1 minus 0 is negative 1. Yeah? And I can simply do what? I want this to be 1 now. Yeah? How do I make it 1? I divide by a negative 1. Yeah? I could divide by a negative 1 here, which is fine. Or I could switch these around. And save myself a space. Okay? So now what do I know? This is your x, this is your y, this is your z, right? So x equal, I mean z equal 1. So now z equal 1. Yes? I can go back substitute. How do I go back substitute? Now I go to this one. What do I read? Y plus z equals 0, right? So we say y plus z equals 0. Y equals negative 1. Because z is 1. Take it to the other side, it becomes negative 1. Correct? Now, I'm going to go to this one. What does that one say? Says x plus 3y plus 2z equal 1. We already know what y is. We already know what z is. We can substitute, right? So we have x minus 3 plus 2 equal 1. Okay? So x minus 1 equal 1. X equals. So now the system is solved. Okay? However, we could, instead of doing this, we could continue. Okay? We could continue with solving the system using the matrix. How do I continue? Well, let's continue from here. Now my next step is, after I got to this, to the last one, now I want to go backward, but I'm going to go upward. What did we do over here? Down, right? Here we go, up, left. So now I want to make this to be 0, this to be 0, right? So the best way to do this, make this 0, I can say R2 minus R3. Okay? If I want to make this 0, I can say R1 minus 2R3. Because if I multiply this by 2, it becomes 2. 2 minus 2 is 0. Okay? Let's see what this step gives me. R1 minus 2 of this. 1 minus 0 is 1. 3 minus 0 is 3. 2 minus 2 is 0. Yes? And then what do I have? 1 minus 2 is negative 1. Let's go with this one. It says this minus that. So we have a 0, 1 minus 0 is 1. 1 minus 1 is 0. Yes? And 0 minus 1 is a negative 1. And the last one is 0, 0, 1, 1. The only thing I'm left with is that one. Notice, now I'm going up, right? I finished with this one. Now I'm going to go to this one. How do I know which one I'm going to go with? It's always row 1, column 1. Row 2, column 2. Row 3, column 3. Yeah? You're done? Then you go backwards. So if I want to make this 0 using this, whichever column you want to make the number zeros on, you go to that row and then you use that column and row number. So if I want to make this 0, well, I can multiply this by 3 and subtract. Yes? So R1 minus 3R2. And then my last step is, let's write it over here. 1 minus 0 is 1. 3 minus 3 is 0. Again, 0 minus 0 is 0. Negative 1 plus 3 is 2. Then we have 0, 1, 0, negative 1, 0, 0, 1, 1. Okay? So now what does that mean? This one and that one are equivalent. The difference, this says x equal 2, y equal negative 1, z is equal to 1. And if you substitute, you should get correct answer. Are we clear on that? Yes? Any questions? Now, suppose for instance, let's not suppose, let's figure out an example that will give me what I want to say. Okay, this is called Gus-Jordan method. Let me see, where is it at? They don't have that in here. Really? Really? Well, in that case, let me say it. Suppose, for instance, you're working on this. Yeah? Let me give you an example. Uh, let's take this system. Okay? Let's take this system. And I want to rewrite it. So now this is your 1, 1, 1, 2. Yes? Then we have 2, 1, negative 1, and a 2. Then we have 6, 3, negative 2, and 6. Yeah? And I want to make this. So first I want to make these two to be zeros. Okay? So here I'm going to say this minus twice that. So it'll be R2 minus 2R1. And this is going to be this minus 6 that, right? So 6, oops. Let's say R3 minus 6R. Let's see what we end up with. So this, so we have on top we have 1, 1, 1, 2. The bottom we have 2 minus 1, 2 is 0, yes? And then 1 minus 2 is negative 1. Negative 1 minus 2 is negative 3. So far, so good. And then we have 2 minus 2 is, 2 minus 4 is minus 2. Yeah? So let's see what we have here. 6 minus 6 is 0. 3 minus 6 is negative 3. All right? Minus 2 minus 6 is minus 8. And then we have a 6 minus 12 should be a minus 6. Okay? Well, all of these are minus. Let me just make them plus. So I can use it for the next step. So I can go ahead and multiply this by 3 and add it to that. Okay? So what do I get? So it is going to be 3 row 2 plus row 3. So we have 1, 1, 1, and 2, 0, 1, 3, and 2, 0. 3 minus 3 is 0. 9 minus 8 is 1. 6 minus 6 is 0. Yeah? So now what do we have? We have z equal how much? 0. We have y equal 2. And then we have x is equal to 0. It was easy to fix. X should be a 1. All right. Well, it didn't give me what I want. Let's say, for instance, 6x plus 3y. I put a 2 here. I should have put a 3 here. Okay, let me put a 3 here. I mean, that one is done. It's solved. It's no problem. What happened if I put a 3 here? So let's see where that equation is. Over here. Minus 3, yes? Let's follow this. And then what do we end up with? In here, so we have a minus 3 or minus 6. That's going to give me minus 3. Yeah? Everything is the same. Now let's go to the next one. What is that the next one is going to give me? We said 3 of this times, so that should be a 9 over here. Let me see. What was this operation? Row 3 minus 6 row 1, so that's a 9. Okay? Because it's a minus 3 minus 6 is a minus 9. So now let's see what that operation is going to give me. Well, first row is the same, second row is the same. Now let's look at the third row. 0 minus 0 is 0. 3 minus 3 is 0. What happened here? 9 minus 9 is 0. Correct? And 6 minus 6 is 0. What does that give me? All zeros. Yeah? What does that mean? It says 0 equal to 0. Remember when we were solving an equation, we said when we end up with a true statement, what that mean? How many solutions? Infinitely many solutions. Yes? So this system, because we ended up with that scenario, and we still have all 3 equations, So therefore, it is infinitely many solutions. However, if I do end up with a scenario that says, so if I change this, for instance, where was it? Make that a 5, and the whole thing will change, and then we end up over here. Let me see what we end up over here. So this one is going to be row 2. So this would be a 5. Row 2 minus 2, row 1. 5, and this is going to be a 1. And then this one. Anyways, let's say we end up with a 5 here. What does that say? 0 equal 5? Is that possible? So we have infinitely many, we have no solution. Yeah? So those are the two scenarios you're probably going to end up with on that. Either you have a solution and the solution is going to come up nice and neat. Infinitely many solution where you have on the bottom row will give you all zeros. And then no solution where you end up with a statement, the coefficients are 0, but the constant is not. Okay? So you have no solution. Okay. I was hoping I'll take a chance to give you the extra credit. Okay, extra credit for test number 2. I want you to do that on Excel. Okay? I want you to do that on Excel. The idea is I want you to write an Excel page that gives you the amortization schedule for any amount for any period. Yes? So for instance, let's say this is your A, this is your B column, right? On A, let's say this is A1. A1. I want you to write loan amount, and in B1, you write whatever the amount is. Okay? We'll talk about any amount you want. It really doesn't matter. In A2, I want you to write the rate. Yeah? And here, I want you to write the rate in decimal. Whatever it is, 3%, 4%. So if it's 3%, you write 0.03, 4%, you write 0.04, and so on. Yes? And then we're going to create numbers as you go. 3, I want you to write N. And in here, I want you to write the amount what N is. If you're doing monthly payment, your N would be how much? 12? Yes? If you're doing weekly, 52, and so on. On number 4, I want you to say I, that's the interest rate, and that's going to be equal, now it's going to be R over N, right? So this is going to equal to B2 over B3. That's exactly what it is, based on what we have here. Depending on which one you call N, which one you call yes? 5 is going to be your payment. This payment must have a formula in there. Yes? What is that formula? That's present value, which this is, you say equal, parentheses, it's going to be the present value, B1. Yes? Times R over N. R over N, which is this one, right? Which is B4, divided by 1 minus 1 plus B4 to the power NT. Oh, I forgot one over here. You can make that a 5, say. I'm not going to change anything. Let's go ahead and make that T. Yes? and let's say whatever amount of years, 30 years, 50 years, what have you. Yes? And to the power negative nt. N would be, say, A3 times, B3, say, B6. Yeah? Okay, now we calculated the payment. I want you to do amortization schedule. The amortization schedule should give you the payment number, payment. All of these will be the same, yes? And out of the payment, I want to know how much interest you're paying, how much principal, and your balance. Yes? I suggest you do it for a small amount of time first. So whatever you end up with a balance at the end, the last period, the balance should be simply what? 0. Okay, so that's basically the idea behind it. And of course, after you do the first row, and you just copy that. Okay. On Wednesday, I'll bring a program. I'll bring an Excel sheet that I wrote, and I'll show you what's going on. Or we'll write it together in the class. And then I'll show you how to do it all. Okay? But this is going to be due on Friday if you are interested in 10 extra credit for your exam. Okay? Any questions? All right, that's it for today.